Hello class, welcome to our lesson today dealing with section 8.4. We've dealt with circumference, distance around a circle, and then distance around composite figures. And then we dealt with area of circles, and then today we're going to deal with the area of composite figures. Before we get into that though, I just want to review a few things about simplifying. This question says, which of the following are equivalent to 12x minus 4? And you're looking for all the answers, not just one answer. So it's just a matter of combining like terms. So for this first one, 12x is the same, but then minus 8 plus 4, so think of a negative 8 plus 4, that's minus 4, and so that would be the same, so that answer would be similar. The next one is not going to be the same because 12x minus negative 1x, which would be keep, change, 12x plus x would automatically be 13x. That automatically is not going to be the same. Now the other part ends up being a positive 4 instead of a minus 4, but automatically that 13x means no good. The next one, 2 times 2x is 4x, and 8x plus 4x is 12x, so that part's in good shape. Minus 3 minus 1. Remember, this is a negative 3 and a negative 1 if you do keep, change to make it adding a negative. And so that would be a minus 4 because negative 3 and negative 1 make negative 4. And on the last one, you have to distribute, and 4 times the 3x would be 12x, and 4 times the minus 2 would be minus 8. And that answer right there is the same as the top one. And so there's 3 of these 4 answers that are the same, are equivalent to 12x minus 4. A few review pieces. I think this proportion question, cross multiplying, should be fairly routine at this point for most students. So x times 2 is 2x, 7 times 11 is 77, and then divide by 2. Remember, this improper fraction of 77 over 2 is not a bad answer. You might have to write it as a decimal or a mixed number, so just make sure you're aware of that as you're going through those situations. The next question deals with graphing lines. Remember, when we graph lines with a point and slope, we want to deal with the point first. So I'm going to plot the point negative 3, negative 1. Negative 3 in the x and negative 1 in the y. So that would be to the left 3 and down 1. That's what that ordered pair would be. And then the slope is negative 1, 4. So remember, slope is always change in y over change in x, or rise over run. But since it's negative, instead of going up and to the right, I'm going to go down and to the right to find that answer. And that would be where my second point is, and then I connect the dots and realize from left to right, this is going downhill, which makes sense because it was a negative slope. Okay, area of composite figures and area of objects in general. This map of the United States is just to show the idea of how area works. So you have to think like each of these little squares is so many square miles, and then however many of those squares that fit on the page or on the state is how many square miles that the state is. Now the problem is most of the states, because of rivers and different boundaries, are very hard to find the area of. For example, Indiana, the top part of Indiana would be fairly easy to find, maybe except for around Lake Michigan. But this bottom part by the Ohio River is going to be really hard to find the area of. Take a state though, like maybe Colorado or Wyoming, that's more rectangular. That's going to be a much easier state to find the area of. And that's kind of how we're dealing with areas ourselves. We have certain objects that we can find the area of very quickly, and other objects that take a little bit more time and more work. Excuse me. One of the first questions we're going to do with area is just the shaded region on a grid. So each grid is 1 square unit. This is similar to the questions we did before with perimeter. Now remember, when we did perimeter, each spot was 1. So like this was 1, 2, but each diagonal was 1.5 as a distance. Now each one that's halfway, like this one, is half of the square, and so that would be a half in that situation. That's more like what you're used to. For the first one, though, I separated this into a square, a rectangle, and then this triangle on the right side. So the square is really easy. There's 4 pieces of the grid, or it's 2 by 2, so that's 4. This rectangle is 6 by 3, and so that's 18, 6 times 3. To find the area of the triangle, though, you should probably just do 1/2 base times height. Okay, so 1/2 base times height. Okay, the height and base are 5 and 6, so 1/2 times 5 times 6 would give you 15 as your answer, and that would be your solution in that situation. The next one has a rectangle in the middle that's 8 by 3, so that's 24. These ones over here that are both the same, I just counted these up. So for example, this one here is 1, 2, 3, 4, 5, and then you have a half and a half, so that's 6 and 6. And then this one on the left side, I did a trapezoid formula. So remember, trapezoid is 1/2 base 1 plus base 2 times the height. Okay, so 1/2 base 1 plus base 2 times the height. And base 1 and base 2 here are 2, and then this is 8. And then 2 plus 8 is 10. So that's where this number comes from. So that's 10. Times the height, however tall it is from base to base, is 3. And then divided by 2 or times a half is 15. But in order to find the area of the shaded region, you got to make sure you add up all the partial areas. And that's the main idea for what we're looking at. So you have a few questions with the grid, and then a few questions that are just shapes and different objects, and you have to add them together yourself. If you're not sure how to find the area of a triangle, I would make sure to write that formula down. Area of a rectangle, I think you probably have. Area of a circle, which we just looked at in our previous lesson. Area of a trapezoid may show up, and you want to make sure you have that formula down as well. The only other one might be a parallelogram, which is just base times height. Okay, the next question is just find the area of this figure, which is kind of the lane and the free throw line of a basketball court. There's two objects here. One is this rectangle here. That's easy to find. 19 times 12, and that would be 228. But then the area I need over here on the left is only half of the circle because the other half of the circle is inside the rectangle. So I just need 1/2 of the area of the circle, which is 1/2 pi r squared. Remember the diameter here is 12, so the radius is 6. So 6 squared is 36 times 1/2 is 18. So that would give me 18 pi for that answer. And I add those together. 228 plus 18 pi feet squared. Or as a decimal, make sure you're able to find that. Use the pi button. And 284.55 feet squared for your final answer for the area of that composite figure of the semicircle plus the rectangle. The next one just has three objects. You have a triangle over here on the left side, so 1/2 base times height. So 1/2 times 11.2 times 4.5 will give me 25.2. That's the area of the triangle on the left side. The rectangle in the middle is just 8 times 4.5, so 8 times 4.5 is 36. And then the area of this parallelogram here at the bottom is 6.7 times 8, and that would be the area of the parallelogram base times height. This one's actually a little bit easier, I think, to find because there's no circle involved, so you don't have to worry about pi at all. Sometimes students get into the scenario of, oh, I'm not sure if I should have pi involved in my answer. Well, it's pretty easy to tell. Is there a circle involved or is there not a circle involved? And then you won't have to worry about that. Sometimes students just get caught up on the direction saying, oh, I need an answer in terms of pi. Well, that's only for circle scenarios, so this one won't have that in terms of pi answer. The next one is find the area of the shaded region, which is kind of the area of these four pieces outside the circle. So to find this, we should find the area of this big square and then subtract the area of the circle. Now, some students get a little concerned and say, how do we know that's a square? Well, since this circle hits at these four locations, that means the distance left to right would be 10, the diameter, and the distance up and down, the diameter would also be 10. So I find the area of the square all the way around, so that's 10 by 10, which is 100, and then find the area of the circle, which is pi r squared. Remember, that's pi times the radius squared, which would be 5 squared, not 10 squared. I get 25 pi for the area of the circle. So to find the area of the shaded region, it would be 100 minus 25 pi. Make sure you're plugging things in correctly to calculators and how you're solving them. You can't do 100 minus 25. You have to find 25 pi first and then do 100 minus that number. Depending on your calculator, you want to make sure that you're plugging things in the right order. You may have to do this in 2 steps versus 1, depending on the calculator that you're using. But you should get just around 21.5 or 21.46 square meters. The next one has a triangle. Okay, so the area of the triangle on the left here would be 1/2 base times height. So the base here is 4. The height is off to the side. This is similar to in section 8.3, we had some radii and diameters that were kind of off to the side. So that'd be the same idea here, 4 times 5 and then times 1/2, which would be 10. This middle one is an area of 5 by 9, and that would be 45 square inches. And then the area on the right is a trapezoid. So remember, that's 1/2 base 1 plus base 2. So base 1 is 9, base 2 is 6.4, and then times the height of 5, and then divide by 2 because of the 1/2 because it's a trapezoid. I find those three areas, I add them together and combine them, and I get my answer of 93.5 square inches. No in terms of pi answer here because there's no circle. One thing to note before we show your homework questions that you're going to work on today, when you're solving these questions, notice the work I have shown on all of these. Okay, I've got work about finding the area of all the objects and then adding them together. Even if it's something really easy like the area of this rectangle here, please show how you found the area, length times width. It's good practice to make sure to get into that, and also that it shows me your process about how you found that answer. So please make sure you're using these as a guide about showing your work. Okay, even if you have these 3 different areas and then at the end say, I added up these 3 numbers to get the answer, that's fine. But even a base case, I want you to show how you got the numbers. So even an easy rectangle, 4.5 times 8, that gives me 36. I need you to be able to show that in order to make sure that we're getting answers correct in those situations. Other than that, your homework is here in section 8.4. There's kind of some different styles of questions. You have some with the grid, you have some composite figures, and you have some work backwards where you have to subtract to figure out the shaded region. Please make sure you show your work. Your teacher will be looking to make sure your work is shown. You can still use a calculator to find the answers, but you got to show your setups on a lot of those questions. Have a good day, everyone.